we are going to connect two AND gates. In this way, the output of the first AND goes to the input of the second one, and this particular connection is known as cascade. And then I put three inputs here, 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 and now I want to calculate the truth table of this circuit, but in this case I don't want to do it by hand, but I want to use a very powerful tool of Logisim, which I show you in a second. You go to Project and to Analyze Circuit, and that's all. In just a second, here you have the truth table of this circuit. You see ABC and the output, and here we have 8 rows, which represent all the possible combinations of values of the three inputs from 000 to 111. And here you see the output, which is equal to 1 only when we have 3 1 on the three inputs. We can check quickly this behavior. If I put 3 1 here, you see the output goes to 1. This is a sort of bigger AND gate. And you see in this case we have, as said, 8 rows. And the reason is because we have 3 inputs. And the general rule is that the number of the rows of the truth table is equal to the number 2 raised to the power of the number of inputs. For example, in this case, we have 3 inputs, A, B, C, so 2 raised to 3 makes 8. The base of the power is 2 because this is a binary system, a system on base 2. We are going to discuss it in more detail in future, but I want to show you that in the previous circuits that we studied in the previous videos, for example, in this one, we have 2 inputs and our truth table has 4 rows. And so 2 raised to the power of 2 makes 4. And in this case, the NOT gate, the truth table has just 2 rows because 2 raised to 1 makes 2. Now I want to show you another interesting feature of Logisim. Instead of opening a new file, I'm going to create a new circuit into the same file. So I give a name to the circuit, and so I have an empty space here. You see, this is the first circuit. The default name of the first circuit in a file is main, but we can change it if you want. And the second circuit, now it's empty. And here I want to try a NAND gate, but this way with number of inputs, I choose 3. So you see now I have 3 inputs in the same AND gate, and I'm going to put the input and output pin. And now I want to generate the truth tables in the same way as before. Project, Analyze Circuit. And you can see that the truth table of this AND with 3 inputs is exactly the same as the truth table of these circuits built with 2 ANDs in cascade connected in this way. So I can choose one or the other circuit, and the behavior is exactly the same. And In conclusion, now I'm going to try the same experiment using an OR gate. So I'm going to create a new circuit. And in this circuit, I connect two OR in cascade. And we are going to see the truth table now. We have 8 rows, of course, because we have 3 inputs. And here you see that the output X is 0 only when all 3 inputs are to 0. And we can quickly check this. If I just put a 1 in any input, you see the output is 1. And as before, we add a new circuit. And here I'm going to try the same experiment, but with 3 input and just 1 OR gate. And the truth table is, surprise, surprise, exactly the same as the circuit made with the 2 OR gates.